Okay. So I'm really going to take my time in explaining this, simply because you're young. And we're going to talk about power. And there is an idea of what power is in normal conversation, and I'm not going to talk about that. And from day one, and I keep saying it, science is a language that is not English. It may use English words, but they mean very precise things. We don't use them like we're speaking English. So we're going to have a look at power, which is the rate of energy transfer. And a couple of sessions ago, I talked about rate. Rate is very important. It is how fast, and that's it. How fast something is happening. And in physics, it's always per second. Well, exactly what does it mean per second? It means, let me text, how much has changed? It doesn't matter what I'm talking about. It could be velocity, it could be speed, it could be the amount of gas given off in a chemical reaction, the amount of heat given off, doesn't matter. It's how much has changed in 1 second. Okay. And that's the meaning of rate, how much has changed, especially in physics. The rate of energy transfer. So power is how much energy has changed, how much energy has been transferred in 1 second. And when we're looking at circuits, there were two things that I really spent a lot of time on. I said, look, this is really annoying. Voltage isn't. Voltage isn't that annoying. It's volts. It's measured in volts. It's got a symbol V. It's nice. It's how much, shall we say, oomph the electrons have got. Current is how many electrons you've got, and current is really annoying. It has a symbol I, and it's measured in amps. And again, if you don't understand it, and we've done it for about 3-4 lessons. It doesn't matter, because the more we talk, the more it'll start becoming second nature. And these are two things. How many electrons you've got, how much charge you've got means the same thing. How much current you've got means the same thing. And you're going to multiply it by how much oomph, how much energy each electron's got. And that's it. So the power of an electric component, a piece of power, is voltage times current. Okay? The thing I don't like, and I find absolutely annoying, is the units of power. I love units. It tells you lots. Power is measured in watts. That's named after, was it Robert Watt? Oh, I can't remember his first name. It's named after a scientist. And I don't like it because it doesn't tell me anything. Not that I'm going to take anything away from the absolute genius. None of that at all. It means I want something that helps me. And I like the unit 1 joule per second. So 1 watt is 1 joule per second. Or power is, the unit for it is joules per second. Okay? Now, per means in 1 second. So power is how many joules, which is a unit of energy. How much energy is transferred in 1 second? Let me type that out. How much energy, and the unit of energy is joules, is transferred in 1 second. And that is very, very profound for me. All right. Now, because it gives me another formula, I'm not going to tell you about that. The actual unit tells me what the formula is. But I'll come back to it. Oh dear. What did I do there? I'll come back to it when we get to it. All right. There's a formula triangle, and some of you guys will have seen these things. I don't like them. Okay. I would rather use proper algebra, but I don't use that with year 7 because I don't know how much you've done in school, and my job is to teach you physics. Okay. Now, the way to use this is you cover what you're trying to find. And what I mean by that, let me see if can I get a circle? I want to get a circle. Give me a shape. There we go. So, can I fill this in? Yeah, let's fill it in. Boom, would it give me there? All right. So the way I look at it is, that's power, that's voltage and current, right? If you want to find power here, So if I say, right, the question asks me to find power, what you do is you cover the P. That's what you're trying to find. So to find power, it is voltage times current. Okay, V times I. If you want to find voltage, you cover voltage. And you're left with power divided by current. If it asks you to find current, you cover current, which is I, power divided by voltage. And these are what we call formula triangles. I think they're really nice in year 7. I don't like them as you get older, but that's my own personal opinion. All right, so let's give you a question. Now, calculate the potential difference. I don't expect you to remember what potential difference is, right? But it is a different word, so potential difference is the same as voltage for the time being. Watts is a unit of power. Now, this is where physics gets really annoying to students. Always label what you've got. So it says calculate the potential difference, which is another word for voltage, through a 48 watt. Watt is the unit of power. With a current, current is I. And this is the tough part. You label them first, like that. You doodle it. And I told you that story used to be about chemistry where I had a, year 13, 18-year-old who got a question wrong because he didn't read the 4. In the same way, this is the really hard part in physics, working out what you've got. So in the questions today, all you're going to do is power, voltage, and current. So it's either going to be P, V, or I, nothing else. You then write down what you've got. Your power is 48 watts. Your current is 4 amps. And then you find the equation you want. So the question said, calculate the voltage, calculate the potential difference. So you go to your triangle. I'm after voltage, so I cover, oopsie daisy, so I cover voltage. I'm left with power divided by current, P over I. You write that down, all right? P divided by I. You know power is 48, so you do 48 divided by 4. That gives you 12 volts. So the potential difference is 12 volts. That's it. All right. Always check your units. I love units. Watts is power. Voltage is either volts or potential difference. Amps is current. And that's it. Okay, so your first step is the easy questions. Power is the rate of, that'll be energy transfer. Power is measured in watts or joules per second. I love joules per second. The symbol for power is P. The power equation is V times I. 1 watt equals 1 joule per second. And then you've got to find the equations by covering the appropriate one. And then you've got some calculations. Okay? You've got some multiple choice ones. As per usual, I'm just going to be very cheeky and delete all my answers to this. I don't care if you're wrong. I care if you attempt it. I'm just going to stop recording, darlings.